Okay, for our first exercise, we're going to create a perfect square on the ground in perspective. Okay? And so the first thing we need to do is we need to locate the edges of our the front part of our square. Okay? So I'm just going to start with we want to go off center because we want to be able to take advantage of our perspective tools. Going off center, I mean, if we're on the center, basically 1 point perspective, but turn 45 degrees, and that means our 45 would be straight up the middle. And that's easy, okay? Um, so what I'm going to do is I'm going to go ahead and I'm going to do my line tools. We're going to start with the blue here. And I've got my vanishing point left and vanishing point right. So okay, let's go up here. I'm going to call this demo 1. Okay. Um, so if I move from vanishing point left here, I can kind of get the left of object edge. Okay. And if I go from vanishing point right across here, I can get my right of object edge. Okay. So this creates two of our lines that would be the square on the ground. Okay. Now, we don't know how far any of these are, but we do need to make a decision. We need to decide on one of these before we can find the other. Okay? So to do that, let's just say I want to get maybe like this length right here. So I'm going to go from vanishing point right and go across the line that converges to vanishing point left. And so this length right here is one face of our square on the ground. This is going to be another one of our faces square on the ground, and this is a line that's one of the faces square on the ground. But I don't know where this line back here goes. I could make a guess. I could come and say, okay, well that feels good, and try to find the square, and I might be able to approximate it pretty good, but we want to be precise. Okay, so what I'm going to do is, as you can see, I have this line right up here from the middle that's going from our 45. And if I come in here, you can see that I've noted that 45. So the idea basically being that let's come up here real quick. Oh, we need to get our orange because orange is where we do our demos. Okay. So here. All right. So if I come up here and I'm going to go ahead and create a perfect square here. So just by taking that square and then going, we'll just say edit, stroke, and let's see. Oh man, my menu disappeared. Okay, so we're at 2 pixels on this one, and that's fine. It gets the point across. Okay, so just like our demo over there, if I have this edge, and this edge are all equal in length, then we need to find this one. Okay, and to do that, all I need to do is do a 45 from one edge to the other, right? And so if I'm at 45 degrees, excuse me, then that will create this length for me. And so I know that I can divide any perfect square in 45 degrees like this, and all of these edges will be equal distance. All right? So the same concept applies here, where if I can go from this front edge here to this 45, which I created, remember, this square is oriented to those two vanishing points. And so the square is oriented in the exact same turn as my 90 degree here, as if we were seeing it from like a drone shot looking down. This has these lines right here are the same as this is. It's just in perspective. Okay. So I can take advantage of this 45 diminishment, and I can go from this corner to that 45 degree line. And when I do that, I get this intersection right here, which now means that this length here and this length are the same. Okay, so to find this length and this length, all I have to do now is go from my left vanishing point. So vanishing point left, and through that intersecting orange line, or the 45 degrees. So if I go from here through here, and it looks like we're going to get kind of wide off of the picture plane, to there, this now represents a perfect square on that ground plane. Okay, so I can then go from this corner to this corner like this, and where they intersect, that would be considered a perspective center of this square lying on our ground plane and turned with the same orientation as this 90 degree turn from our station point. So this now becomes a perfect square in 2-point perspective, laying on our ground plane at this degree. Okay, so this is a very, very valuable tool to have, and is very useful for, like if we want to find the footprints of buildings and that kind of stuff. We can use this as a perfect unit, because now if I want to like find how to duplicate this through space, we can then find our center. So I can go from vanishing point right through that perspective center like this. Okay. And now I have the center point, so I can go from this corner through this far edge at that intersecting center right here. Okay. Until it reaches that point right there. And then I can go from vanishing point right through that intersecting point as well. And we can see how we're getting diminishment as we get closer to the ground, to the horizon line, which is basically just going to copy that square over. So this square now and this square are the same size. They're just getting diminished. And we can test out that by using our measuring line here. I could just go out and create this out and then use a measuring line across here, make sure that length, and then double that length and come back over. And they should be equidistant. But we'll get into measuring points and measuring lines when we do the cube. So, and then I could just continue that all the way through. So I could just grab this, go through that X right there. And that's it. There we go, at 45 degrees in perspective space. And then we go again through here, right there. And now this square, and this square, they're all equal going back in 3D space on the ground plane going through. So that's really useful to know. And that's just what we call the Xing and duplicating method. And it's a really, really useful tool to create very uniform measurements in 3D space. Okay. Now, if you wanted to do it vertically, you could do basically the same technique. So our 45 reacts a little bit differently, and we'd have to think about our 45 on our station line rather than our horizon line. We'd have to think about that 45 degree. Now we know that this point here is 45 degrees. So we could refer back to that and until we cross the center of vision, which then would become, forever diminishment or just a straight line. Then we could use that going down all the way through. Okay. But I think that measuring lines are a little bit more sophisticated and tend to feel more accurate to me. They're both accurate, but with measuring lines, I feel like I can get things to feel a little bit more sophisticated. So we'll do that. Okay, so there it is.